Hi everyone, this is Dr. Saida Falafini. In today's class, we are going to first go through a couple of examples related to the queuing theory. We are going to read some sections of a problem statement, and by reading that, I want you guys to think about if that part of information is related to the arrival process or service process, and how you can extract the information that you need to be able to analyze any queuing system. Then we are going to go through a simple example, building a simple model in Arena, and by doing that we are going to get familiar with all different sections of Arena. Okay, so let's go through the queuing system as examples first. By reading each one of these lines, I want you guys to tell me first if this information is related to the arrival process or service process. Then I want you guys to tell me if this information it is giving you arrival rate or inter-arrival time, or service rate or service time. And lastly, I want you to tell me if this information is related to a fixed arrival process or service process, or it's a random process. Okay, so the first example says 15 customers per hour go to a CVS pharmacy. So what type of information is given to us here? Yes, that was correct. If the arrival rate is 15 customers per hour, then inter-arrival time is 4 minutes. Okay, so guys, pay attention. We always say arrival rate. We don't say inter-arrival rate. Arrival rate or inter-arrival time. We don't say arrival time. We say inter-arrival time or arrival rate. Okay, these are the correct terms. So, and then is this arrival rate or inter-arrival time fixed or random?
They don't explicitly tell us, but because we're talking about customers walking into a real world store, I would assume that it's random.
No, this sentence is all you have in the problem statement.
Since we don't have an average term in the sentence, I would assume it to be a fixed one.
Exactly. Since you don't see, remember in previous session we said that the keyword is the word average. If you don't see average arrival rate or average inter-arrival time, that means that arrival rate or inter-arrival time is fixed in this problem. And here we don't see the keyword average. That means in CVS, exactly 15 customers per hour go to the pharmacy. Yes, it may be far from, it definitely is far from real world, but if that's the sentence in our, in our problem statement, then that's all we have. And based on this sentence, arrival rate is fixed. Any question? All good? Okay, let me go to the next one. Boeing receives on average 16 orders per hour. Tell me if it's related to arrival rate or process. I'm sorry, if it's related to arrival process or service process, and what type of information is given to you?
Well, it's related to arrival process, and it was given arrival rate.
And that arrival rate is?
Arrival rate is 16 orders per hour.
Okay. What is the inter-arrival time? I know it's not easy to calculate.
So the inter-arrival time is 3.75 minutes.
Okay. Thank you for calculating that fast. And remember the formula I said, it was 1 over arrival rate. Okay, so just remember you can calculate that formula clearly. This is one example, because in previous example, 15 customers per hour, that's easy. That means 4 customers per hour. 15 customers per hour, that means 4 minutes between the arrival of the customers, right? So you can easily calculate the inter-arrival time. But in the second question, 16 orders per hour doesn't tell you, like, it's not an immediate calculation to say, oh, every hour is 60 minutes, so that means 2 minutes or 3 minutes inter-arrival time. So the formulas that I mentioned in the last 2 slides of the queuing system concepts, those help you to calculate the inter-arrival time in the problems if you need to. 1 over arrival rate gives you inter-arrival time. 1 over service rate gives you service time. Okay, so remember to make sure to you guys know how to use those formulas. And then the other question I have is this arrival rate fixed or random?
It's random.
Okay.
Because, average.
Because of the keyword average, this arrival rate is random. And what other piece of information you need in this problem?
Service rate.
No.
No. Distribution.
Yes.
Oh.
Yes. Right now we need, if you see average 16 orders per hour, that means the inter-arrival time of the orders is a random variable because of the keyword average. So you need to also have the distribution of this random variable. So one other piece of information you need here is, for example, me to tell you that inter-arrival time has exponential distribution. Okay, so then you know that this inter-arrival time is random. It has exponential distribution. And what is the rate? 16 orders per hour is the rate. Every 2 minutes, one call is made to DMV. Tell me what piece of information is given, arrival or process, and what type of information it is.
It's inter-arrival time.
It's inter-arrival time, perfect. How much is it?
It's one call per it's 2 minutes. Is it?
Yeah.
The inter-arrival time?
Inter-arrival time, just simple, 2 minutes. That's it. And
Yeah.
is it fixed or variable?
It should be a variable, I think.
No, that sentence is all you have. From that sentence, what do you conclude?
I think it's random.
Remember, we said there is a keyword that you have to see to be able to.
Yeah. There is no on average, so it's fixed.
Okay. So, guys, when you read the problem statement, everything related to the problem is there. Don't think like yourself. Don't say, if I give you a problem related to DMV and I say every 2 minutes, one call is made to DMV, there is no keyword. I don't say on average every 2 minutes. That means inter-arrival time is fixed, right? That means inter-arrival time is fixed. It's 2 minutes. So that's it. Don't say, no, in DMV, the inter-arrival time is random, so this is random, okay? The problem statement is all you have. So you have to conclude based on the information that is given to you on problem statement, okay? So don't forget, for randomness, you have to see the keyword average, okay?
Okay, I got you. Thank you.
Okay, sure. And so here is fixed. If it was random, I would tell on average, every 2 minutes, one call is made to DMV. Okay? In that scenario, you see the keyword average, and that's random. So then what else do you need in that scenario? In addition to the inter-arrival time, what else do you need? If I tell you on average, every 2 minutes, one call is made to DMV.
Then I need the distribution.
Then you need the distribution of that inter-arrival time as well.
Yeah.
For example, I tell you inter-arrival time has normal distribution with variance of 4, for example. You need also that part as well.
Yes.
Thank you.
Thank you.
Next, Bank of America receives one customer every 5 minutes on average.
This is Bible process. Sorry, you can. This is Bible process, and it's given arrival rate at every customer for 5 minutes, which translates to 12 customers an hour. Inter-arrival time, and the arrival rate, it's 12 customers per hour, and this is the distribution. It's random, not fixed.
It's random, and so the other piece of information that you need is the distribution of random of the inter-arrival time. So I can tell you Bank of America receives one customer every 5 minutes on average. And for example, the inter-arrival time has gamma distribution, for example, something, and then they'll give you the rest of the parameters that we need for the distribution, for that distribution. Okay, David. Next, drilling machine processes 60 parts in an hour on average. Who was the person who wanted to answer right in parallel with David? This is yours.
Oh, it's me.
Okay, Yelena.
This is related to the service process, and in this statement, the service rate is given.
Okay, perfect. This is related to the service process, okay, because we are talking about processing time on a machine, and we have given you service rates. A machine can process 60 parts per hour, and is it fixed or random?
It's random because the keyword average.
Average is there, and what else do you need to have here?
I need to have the distribution of the service rate here.
Of the service time. Okay.
Yeah, service time. Yeah.
Service time. So then, I can tell you that drilling machine processes 60 parts in an hour on average, and the service time has exponential distribution, for example. Okay. So you need because of the word average, service time is random. So you need to know the distribution of that random variable to have a sense of the spread of variability around the mean. Okay, thank you, Elaine. Next, late machine processes 20 parts per minute.
Service rate.
Service rate, and that service rate is?
20 parts per minute.
And
120 parts per hour.
Sorry?
120 parts per hour. Yes.
Yeah. And then is this fixed or average? Is this fixed or random?
This one is fixed.
The service in this problem is fixed because you don't see the keyword average. Perfect. Okay, guys. Before I go into the arena, let me talk about a couple of concepts that we will use. Remember in previous session, in previous week, I showed this chart to you, this graph to you as a representation of a queuing system. For example, parts arrive to a manufacturing process, they get processed at this machine, and then they leave the system, okay? So when we want to build a simulation model of this, we use a couple of terms, okay? So one of them is locations, okay? So locations are where things happen in a simulation model. So in this example, how many locations do you think we have? How many parts, how many places we have where something happened on the parts that arrive to the system?
There's only one.
It's only one. There is only one machine. We call it here, for example, server. When we get these parts, do some processing, and then send them out. Okay, so we call them as locations in the simulation model. Okay, so if you have a production process, when parts arrive, they go on machine 1, they get processed, and then they go wait on a queue, and then they go to machine 2 and then get processed, and then they leave the system. Here in this example, we have 2 different locations. Okay, so that's one. The other concepts that I want to talk about is the concept of entity. Entities are anything that comes to the system, gets processed, and leaves. The parts, the customers, anything that has this nature, they come to the system, they get processed, and they leave, they are entities. So how many types of entities we have here? Parts arrive to this manufacturing process, they get processed, and they leave. How many entities, how many entity type we have?
One.
We have only one entity type. Parts are the only one. We have many of them, like let's say I tell you on average I get 20 parts per hour. Okay, so obviously I receive a lot of parts, but all of them are entities under just one category, and they are called parts. If I, for example, I'm simulating a manufacturing process in which part A arrives from, for example, supplier A, and then we also have part B that come from supplier B, and then they go to assembly machine and they get assembled and so forth. In this example, there are two types of entities that arrive to the system, part A and part B. Obviously, I have a lot from each one of them, but there are only two types of entities, okay? Sometimes, for example, if you want to simulate a hotel, in this service industry, we always have the VIP customers and the regular customers, and they are treated differently. VIP customers may not wait in the line, and they may get faster service and so forth. So in that scenario, sometimes you need to define them as two different entities that come to the server in the hotel industry, so that you can treat them differently in the simulation model. In that scenario, you have two different entities. Both of them are customers, but one type of entity is regular customer, one type of entity is the VIP customers. Okay, so just keep that in mind. And then all of us know about the arrival process. We have to also get that pieces of information, and the service process as well. So I want to talk about location, entities, arrival process, service process, and yeah, you need to definitely know these four pieces of information before we jump into the simulation model, into the simulation. So now let me go and open my arena. Okay, so everyone has the arena open, right? So in this, when we want to build any model, this is basically the view that we see. Okay, so now let's see what is in this picture. So when we want to build a model, they appear in this part of the simulation model. We call it flowchart window. Okay, so let's go, all of us, let's go to browse examples, click on the assembly line example, just as an example. So when you see arena models, the extension is DOE. If you see a file, because when you generate arena model and you simulate the model, a lot of other files are also created at the same time. The file that has the model has the extension DOE. Okay, let's just click on the assembly line if you can see, if you can. Okay, so I just want to, I don't want to run or anything about it, but I just wanted to have an example where a model is here. Okay, so this view, this part of the window where you see your simulation model is called flowchart view. And the reason is that when we put the model together, it looks like a flowchart. Okay, but here is where we build the model. And the top part is our toolbar, obviously, and we will learn over the models that we will build. We will learn how to use each one of most of these elements that we see on the toolbar. On the left, we see what we call as project bar. Okay, you see the name on the top. So here we see here is what we call as project bar. If you click on any one of these, for example, if you click on on basic process, do you guys have basic process? On the left, on the project bar, do you see a menu, a template called basic process? You just click on that and it opens for you. Okay, so these parts, for example, basic process has a lot of elements that, or modules, we call this as modules. The create module, dispose module, process module. These are the elements that we are going to use when we are building the simulation model, okay? Instead of giving you all the possible elements that exist in Arena in a long list, Arena has classified them into different categories. Basic process, for example, it has the ones that we will use in pretty much every model. If you want to build a simple basic model, basic process, the modules that are available at the basic process panel is enough for us, okay? As we are going to build more advanced models, we are going to use other panels as well. For example, advanced process, advanced transfer, and so forth. As you click on any one of them, they are going to open. If you don't see all of these, don't worry, I'll tell you in a second how we can potentially see that. But just click on the basic process, let's stay there. So each one of these, as I said, basic process, report, for example, navigate, and so forth. Each one of these are called a panel, okay, or a template. So each one of these is called a panel or a template. Inside the basic process panel or basic process template, there are a lot of little elements that we'll use when we are building a model. These little elements are called modules, okay? And if we wanna get rid of some of these templates or bring them to our project bar so that we can use them in building the simulation, go to the file, click on the template panel, and you see attach and detach. If you click on the attach, a window opens, and here you see the list of all possible panels, all possible templates that are out there for you. Basic process, for example, is the one that we already have. For you guys, I would say click on the advanced transfer. There's a good chance that you guys don't have that, don't have that one. Okay, so click on the advanced transfer, and then that panel is added to your project bar. Okay, so this part is just, as I said, it has all these little panels, all these panels that have the modules that we are going to use in the simulation, building the simulation model. We are going to start by using the basic process panel. That's the one that basically has pretty much most of the things that we need for a simple model. But as we go through more advanced model in future sessions, we are going to use the other panels as well. And you learn how to bring a panel, going to file, template panel. If you want to bring another panel that you don't have it right now, you can attach it. If you want to get rid of a panel, you can detach it. For example, if here I have chosen advanced transfer, and then I go to file, import template panel, and I say detach, it takes away that template from my project view. It's still there. If I want to bring it back again, I have to go to the file, template panel, and attach it again. But if it's just, if you have too much things in your project bar and you just want to have a more simple view, you can get rid of some of these panels by detaching them. Okay. So go to in the model that you have open the basic process, open the basic process panel, and just click on the process. Okay. Do you see this spreadsheet?
Yes.
Okay. So this part, this lower part is called Spreadsheet View. What is it? It's pretty much shows everything that we can see by looking at here at the bottom as well. We are going to build a simple example, and you will see how basically anything that we can see on the top can be seen here as well. This is just an alternative way for you guys to see the modules that you're going to use in your simulation, and have it as a way to change some of the things related to the module. For example, if the unit of time for processing a part is not minute and it's in hour, you can change it here, but you can change it in the flowchart view as well. I will show you guys how. But this lower part is called Spreadsheet View, and it's just an alternative way to look at some of the properties of the things we are going to use in the simulation model, and I will talk about it in an example in a bit. Okay. If you go to the view, here, do you see a split screen? Okay. Click on that. You see the spreadsheet view is gone. Okay. So that means it is not going to split your screen for you between the flowchart view and the spreadsheet view. If you go to view again and click on the split screen, it splits the screen for you so that you see the flowchart of your model and also the spreadsheet version of everything that you have put in your model. Okay, so this is just a matter of comfort. Like sometimes you are building a big model, you need all this space here to show the flowchart. Okay, in that scenario you can get rid of the spreadsheet view, but sometimes it's easier for you to have the spreadsheet view as well. Okay, you are going to show it. Okay, so if this is a spreadsheet view, if you want to get rid of it, you can click on the split screen, and if you want to bring it back, you can again click on the split screen. When you split the screen, that means it splits it between the flowchart view and the spreadsheet view. Okay. And the other thing that we have here is here at the very bottom, this bar here at the very bottom is called the status bar. When we run a simulation model, you can see information related to running the simulation model here. So when we run the simulation model that we are going to build, I will show that to you. So for example, you want to run a simulation model for 100 hours. Here at the bottom, you can see how the timing of the simulation goes forward and so forth. So that's why they call it status bar here at the very bottom, because that's where you can see the status of the simulation when you run it. Okay. If you also go one more time to the view bar, and you see project bar is checked. If you check project bar, remember it was this left panel here. If you click on that, the project bar is gone. Again, this is for sometimes you want to show maybe the structure of the simulation model to the customers. You are in a presentation, you don't want to show the project view or spreadsheet view, the project bar or spreadsheet view or anything. You can get rid of them and just show the flow chart of the simulation model. But as you are building a simulation model, of course, you want to have the project bar because you pick the elements of your simulation from the project bar. Similarly, for the status bar here at the bottom, you see, if I click on that, the status bar is gone. I don't see anything like as a status bar, but if you click on it, the status bar is back. Okay. And the other thing is debug bar. If you click on the debug bar, you see there is a debug window at the debug section at the bottom. So sometimes when we build a simulation model and we get errors, and here we can always show the debug section and see and get a better sense of what is the error term and why it's not working and so forth. Okay, but I deactivate it most of the times because it's just extra space, and if I need it, I will bring it and take a look at it. Otherwise, for most of the times, I just don't show the debug bar. Okay, and in the project bar, in addition to the basic process panel, which has a lot of the things that we are going to use at the start, the other two panels that you may use are report bar. So when we run the simulation model and generate the report, you can come to this panel and see some of the information related to the things that the simulation generated for you. We talk about that in the example that we are going to go through. And the other thing is the navigate bar. So in the navigate bar, there is a blue window. As you can see, you can drag this blue window and move it around. Okay, so again, this is good because sometimes you build big simulation models and you don't want to share everything on the screen. So you want to just share part of it. You can move this blue window, and then you can just focus on the parts that you want to show. Okay, so if I bring blue window here, so it includes all the models and so forth. Okay, so here for this example, it may not make sense as much because the structure of the model is squeezed in this little white rectangle, but for the models that pretty much fill all of our screen, all the gray area, then presence of this window helps because it can tell us, okay, what to show in that big in the screen that we can see here. Okay, so yeah, so the main templates, the main panel that we are going to use will be basic process for the next 1 or 2 sessions. Go to the file menu and press new, or just from the menu here, there's a new button, just click on that so that we get a new structure, a new model, okay? If you want to save this, guys, for this class, I want every week, I want you guys to create a folder for that week on your, wherever you save your models. So I want you guys to have one folder, create one folder right now, everyone. Create one folder that is called ISE 580 Fall 2020. Okay, so create that folder in your computer. I will ask you guys later to share the screen and I want to see this folder structure. Okay, so everyone create a folder and name it as ISE 580 Fall 2020. Or if you have it, that's great. Inside that folder, we are going to create one for every week of class. So in every week of class, we are going to create a folder. So this is week 2. The name of the folder will be week 2. Okay, so in the folder for week 2, we are going to save everything that we create in that week. Then we'll create a folder for week 3, and in that folder, we save everything we are going to create for that week. Okay, and I also want you guys to use the naming convention that I'm going to tell you, because in the naming convention that I'm going to tell you, we specify, okay, what this model is going to do and what we are going to learn. And that is helpful, especially for the exam and later when you want to get back to the models and review some of the things that you have learned. Then looking at the name of the model can help you. Oh, we learned this concept in this model, so let me open that model. Okay, and also in the future, sometimes we want to work on the models we already have built. So I'll tell you, go to week 3 and open the model. Go to the folder for week 3 and open the model. Blah blah. Okay, so in that case, when you use this folder structure, you can easily go back to the folder for week 3, open that model, and everyone can continue the class really fast. So you don't need to search between a lot of models that you have and so forth. Okay, so for this week, create a folder, as I said, for the class ISE 580 Fall 2020. In that folder, create a folder for week 2. So call it week 2, and inside that, when you create this new model, let's save this. So press the save button, and in that, and then just save it introductory model. Okay, introductory model. Just call it that. Because I told you guys that basic panel is the panel that we are going to use right now for pretty much most of the models that we want. And if we want to create any one of these modules here, we have to, if we want to bring them to our model, we have to drag and drop. So what I want to do right now, what I want you guys to do is to click on the create module, drag it and drop it in your model. Okay, so then you have to see something like what I have on my screen. And as we go forward, make sure to save it just so that you don't, here we don't, we want to just practice and play with the modules that we have. But make sure to save it in case you want to get back, refer to it later for refreshing your mind and everything. So drag the create module and drop it in the flowchart window. That way we bring this module into the window. And that's the drag and drop basically is the method for bringing any module into the simulation model. So now for these modules, as you can see here in the basic process template, you see some of these modules that are like geometric like shapes like rectangle, triangle, and so forth. And you see some of them that are like spreadsheet. You see the attribute entity, queue, and so forth. So the modules on the top, when they are yellow, when they have yellow colors, we call them as flowchart module. And the one at the bottom that have like a spreadsheet view, we call them as data module. Okay, so flowchart modules are the ones that basically are going to help us to build the flowchart or build the simulation model. Remember that flowchart view of the simulation model? So we use flowchart modules for that. And we bring them into the simulation model through drag and drop. However, data modules, are not used in the model directly. You cannot drag and drop the data modules into the simulation models, but they are there and they show information of some of the things that we build in the simulation model. For example, we will see that when we create entities in the simulation model, how we are going to do it, and for that one, we don't bring a specific module that shows, a specific flowchart module that shows entities. I show you how we are going to do it, and then you will see that the information of the entities that are created are just shown in the entity module, okay? So just keep that in mind as we go through the examples and we work with this, so you will have a better sense of what is the difference between these modules. But just in general, we have the flowchart modules. They are the ones that we can drag and drop into the simulation model. We use them to build the flowchart of the simulation model. And we have entity modules that are more behind the scene type of things, and they show the information related to a lot of the things that we create in the simulation model. So that's one. Some of these panels use different shapes to show different flowchart modules. In some of the modules, in some of the templates, for example, in advanced transfer template, all of them have the same shape. They just have different colors to represent different things. And that's fine. You don't need to memorize that or anything. Just know that sometimes we see different shapes for different modules, especially flowchart modules. Sometimes we see different colors, and that's fine. It just depends on how different things, different modules in that specific panel have been organized and so forth. Okay, so let's go back to the basic process panel. We put the create module here, right? So double click on the create module. Double click and you see this window. Okay. So this is a create module, and it's a create flowchart module, okay, because it's one of the flowchart modules. So everyone see this window, right? Everyone has this create window that has been opened, okay? So here with create module, we are going to capture the arrival process of the simulation. We are going to mention what has entered into the simulation model, the entities that enter the simulation model, and frequency that they come to the simulation model. So basically, we use the create module to tell the simulation anything or everything about the arrival process of the simulation model. So let's give a name to this create module that you have created. Let's say parts arrive to the system. Okay. So that's what happens here. And then it asks you to specify the entity type or the name of the entity. So in this example, let's assume parts come to a manufacturing process and they are going to go through the process. So my entities are basically parts. So let's, here I'm going to mention part. Okay, so type part as the entity type part. And then here, it says time between arrival. What is the other name for time between arrival?
Arrival time.
Inter-arrival time.
Yeah, exactly. This is time between arrivals or inter-arrival times. That just shows you right away when we wanna specify the arrival process in the simulation model, we have to give the inter-arrival time to the simulation model. So even if I give you arrival rate in the problem statement, the information that you need to enter the simulation model is inter-arrival time. So you have to transform that arrival rate to inter-arrival time and then enter that inter-arrival time to the simulation model. This is extremely important, guys. Make sure you don't make this mistake. I have seen students who have submitted their final model and they still have put the arrival rate in this part of the simulation and so forth. So what we need to enter the simulation model through the create module is inter-arrival time. So if the problem statement is giving you arrival rate, you have to transform it to inter-arrival time, and then you have to put it in the simulation model. Okay, so make sure you are clear on that. Okay, so for the inter-arrival time or time between arrivals, if you open the type menu, we have a couple of options. So for example, if it's fixed, we use constant. Okay, I tell you inter-arrival time is 5 minutes. It takes 5 minutes between the arrival of every 2 consecutive customer is fixed constant. So you say constant and the value is 5 and the unit is minutes. Okay, so that's what you would enter. If I tell you on average, if I tell you the inter-arrival time for customers that come to the Bank of America is 5 minutes, that's what you enter. Constant, 5 minutes, and 5 and minutes, okay? But if it's random, for example, if it has exponential distribution, you choose expo, that's abbreviation for exponential distribution, and then you can put the value of the inter-arrival time. For example, I tell you average inter-arrival time for customers that are coming to Bank of America is 5 minutes and is exponentially distributed. Then you put 5, which is inter-arrival time here, and then the distribution is exponential and the unit is minutes. Okay, so just pay attention. So average of inter-arrival time for customers that come to Bank of America is 5 minutes and is exponentially distributed, is translated to this row into the simulation.
Professor, if we're given an average inter-arrival time, and will we always be given the type of distribution, or should we assume that for arrivals, the default distribution is exponential?
No, usually in the statistics, arrivals usually have exponential distribution. Okay, but in this class, I give, if something is random, if you see the term average, I should have given you the distribution as well. If it's not there, make sure to ask me. Ask him, that's a mistake. If you don't see that in a homework or in an exam or anything, ask me. In this,
okay, thank you.
If I tell you average thing, which means randomness, I also should give you the distribution as well. But you're right. In the real world, usually inter-arrival times for arrival of customers or parts usually have exponential distribution. And schedule, we will use it just so that I give you a quick introduction. Sometimes, let's say in a supermarket, customers may come a lot faster between 8 to 10, and then we have a slower arrival between 10 to 12. And then again, around lunchtime, a lot more customers come, and then it gets slower. And then around afternoon, when everyone leaves the work, again, more customers come. So the arrival rate, the speed of the arrival, the frequency of the arrival changes in different parts of the day. In those scenarios, we define a schedule, which we will learn later how to do it, and say between 8 to 10 a.m., this is my arrival rate. Between 10 to 12, this is my arrival rate, and so forth. And then we tell the simulation that use this schedule for mimicking the arrival of customers to this system. Okay, in that scenario, we will use a schedule. Again, we have examples on that. We will do it. You will learn it perfectly. Don't worry about that. And then the expression is another scenario that we can use. If we use expression, then you have a lot of more options here as well. For example, even the exponential, which was one of the options here, is available in the expression as well. You write expo means exponential, and then in parentheses you write the average of the inter-arrival time. If it's something is normal, you write norm, N-O-R-M, and then mean and standard deviation. If it's something, if the inter-arrival time has triangular distribution with a minimum mode and maximum, you write that, you just write TRIA, mean, mode, and max, in uniform and so forth. Okay, so let me talk about 4 of these distributions that we use a lot when we want to create a model. And let me just write them. If the inter-arrival time has exponential distribution, or even service time, it doesn't matter. The way to write it in the simulation model is expo, and then here in the parentheses we write mean. This is mean or average of the inter-arrival time. Okay, so the keyword is expo. So that's what we write. So here, for example, when we said every 2 minutes, one call is made to DMV on average, and the inter-arrival time has exponential distribution. If I tell you that, so every 2 minutes, one call is made to DMV on average, and every 2 minutes, one call is made to DMV on average, and the inter-arrival time has exponential distribution. In that scenario, I have given you the inter-arrival time. You see the keyword average, and I'm telling you the distribution of inter-arrival time is exponential with 2 minutes. Then all you need to write is expo 2. And expo keyword is not case sensitive, so you can write it in any way. Okay, so we write it like that. The other one, the other type of distribution that we use actually a lot in this class is normal distribution. So I tell you that, for example, the inter-arrival time for customers that come to a bank has normal distribution. In that scenario, you use the keyword norm, and then you need to put the average with, let's say, 5 minutes and standard deviation. Okay, so this is what you see here as well. For normal, we see average and standard deviation. So average 5 minutes and standard deviation 2. Okay, so in that scenario, you write norm 5.2 for the inter-arrival time. So I tell you that, for example, customers that parts that come to a manufacturing process to get processed, the inter-arrival time of these parts has normal distribution with average 5 and standard deviation 2. So that's what you write. For the inter-arrival time, it has normal distribution with average 5 and standard deviation 2. Just make sure, guys, pay attention to this one. In statistics, when we use this term for showing the parameters of normal distribution, the first term is always average, and the second one is always variance in statistics. But in the simulation, when we use this notation, the first one is always average, and the second one is always standard deviation. What is the relation between standard deviation and variance? Standard deviation is the square root of variance, okay? So if I tell you, for example, the inter-arrival time of customers that come to a bank has normal distribution with average 5 and variance of 4, make sure you don't write just right away, just jump on it and just write, oh, it's 5 and 4. No, I tell you average 5 and variance of 4. That variance of 4 means a standard deviation of 2. Okay, so just pay attention to that as well. When you read the problem statement, is it giving you the variance or the standard deviation? What you need in the notation is the standard deviation. If I tell you that the inter-arrival time of customers that go to a bank has a uniform distribution with minimum 2 minutes and maximum 4 minutes, okay? That means the inter-arrival time of customers that go to a bank is random. It changes from customer to another, and it changes uniformly between 2 to 4. Right? When I tell you minimum 2 minutes and maximum 4 minutes, that means it changes between 2 and 4, and any number in between is equally possible. Okay, it's not that, for example, 4 happens more often, or 2 happens more often, or 3 happens more often. Any number between 2 to 4 is equally possible. So in that scenario, we write it as UNIF, U-N-I-F, minimum 2, and we put then the mean and then the max. Okay, so that is uniform 2, 4. Okay, so that shows the inter-arrival time of customers. It has uniform distribution with minimum 2 and maximum 4. Okay, let me write the notation here as well if you guys are taking notes. So this is norm, we put mean, and then standard deviation. So that's norm factor. Okay. For uniform, we put mean and max. And for triangular distribution, if you have seen the triangular distribution, is a type of distribution that has a mean and has a max, and one of the numbers in between mean and max is the one that happens a lot more than the rest, and we call it mode, the one that happens most. Okay, so for the triangular, we say TRIA, mean, mode, max. So this is them. So if I tell you the inter-arrival time of parts that come to a manufacturing process has triangular distribution with a minimum of 3 minutes, maximum of 8 minutes, and let's say mode 6 minutes. So we say 3, 6, and 8. So minimum 3 minutes, maximum 8 minutes, and mode, or the number that happens more often, is 6 minutes. Okay, so in that scenario, you can write it as a triangle, 3, 6, 8. And the distribution of a triangle distribution is really similar to a triangle. With the minimum of 3, it goes up to the number 6 and it goes down to the max. So in that scenario, we write it as triangular. I mean, we can use obviously a lot other options for the distribution. If I go here, for example, click on the expression, you see a lot other distribution as well. But the ones that we use a lot in this class are exponential, normal, triangular, and uniform, and that. So if the inter-arrival time has a distribution, something other than exponential that you already have here, you can choose it as expression, and then here you have the options for other type of distributions to put it here. Okay, and also here is the unit. Is it 5 minutes? Is it 5 seconds? Is it hours? Is it days? So you can specify all of them here as the units, and that's important as well, guys. I have seen simulation models when you enter everything fine and so forth, but you forgot to change the minutes. For example, if all the processing times is based on hour, if the inter-arrival time is based on hour, but you forget to change the unit of arrival from to hour and just leave it as minute, it will destroy your simulation, because in this simulation, parts are arriving to your simulation model a lot faster, but they are leaving a lot slower. So your system will just the number of entities in your system will go to infinity in a couple of seconds, and you get errors and the simulation doesn't run and so forth, and you don't know what's going on. I have done everything correctly, but the simple thing that you have forgotten to do is to just pick the right unit of time for the inter-arrival time. So pay attention to every single thing that we did specify here. One other thing that I want you guys to do is that if you pick expression, as I said, one option is to click here on the drop-down box and just pick one of these distributions that is there. One other way is to just right-click on the expression window, just do the right-click, and then you see build expression. If you click on the build expression, it gives you the possibility of writing even more complex formula. For now, we are not going to use it. I just wanted to show you that. So just close this. But when you pick the expression, you can not only pick from these standard distributions that Arena has already listed for you to speed up your work, but you can always right click on the expression window and you can choose build expression, and you can even write a lot more complex formula here if your inter-arrival time happens to be a complex process. Okay, the next thing that we have to specify in the create module is entities per arrival. This is important. What does it show? It shows how many entities come to your system in each arrival. If you have the number 1, that means entities come to the system one by one. Every time the simulation generates an entity and is coming to your system, it's just one entity. We have also models in which we want to calculate, we want to show that the entities don't come one by one, they come in groups. For example, if we are modeling a restaurant, we should allow the entrance of entities to our model to happen in groups as well. So sometimes people go into a restaurants in groups that varies in size between 1 to 5. Okay, we can show all of that in this part of the box, in this part of the create module. We will see later how we are going to do that. But entities per arrival shows that in each arrival that happens to the simulation, every time that the arena generates an entity and it wants to come to your system, are they going to come one by one, or they are going to come in a group? If you are modeling a manufacturing process that receives parts in batch to process, those batches are not basically one by one. If they come in batches of 10, then in every arrival of entities, you receive 10 entities. Okay, so you need to capture those in here. And again, we to those parts with examples, we'll explain everything. What I want you guys to know right now is entities per arrival shows how many entities enter the simulation, enter the system every time an arrival is generated. Every time that entities come to the system, how many entities come together. If you are modeling a batch, a production process, when parts are processed in batch, you can consider that here. In batches of 10, then in every arrival, 10 parts arrive to your system. What's the question?
Can this be an expression as well? I mean, can you enter some random variables into this box as well?
Yeah, so yeah, as you can see, pretty much in every time you open the windows for any one of these modules, if you can enter a number in that little box, you can always build an expression as well. So here I enter 1, that means entities come to the system one by one. That's a box in which I can enter a number. If I right click, I also have the option to build an expression.
Okay, thank you.
In that scenario, yeah, if your number of entities that come to your system follows a more complex arrival, entities per arrival, okay, yeah, we can write an expression for it. For the infinite, so max arrival. Max arrival shows how many entities have to come to your system. When we put infinite, it means for as long as we run the simulation, entities will come to the system. Entities were generated based on the arrival process that we have identified, and they will come to your system. There's no end on that. So, and that's usually for most of the simulations that we define. We usually want the simulation to just let the entities to come to the system for as long as we run the simulation, generate the entities and send them to the system for as long as we rerun the simulation. In that scenario, we put infinite for max arrival. But if you are modeling a system in which the number of arrival is limited, for example, you are modeling the cafeteria of a university, and that cafeteria receives 100 students per day. In that scenario, if you want to simulate what is happening in the cafeteria, you don't want to let infinite students potentially come to your system, okay? So then in that scenario, the number of students that come to your system, the number of entities that come to your system is going to be 100. So for the max arrival, then you type 100. That means the simulation will run till 100 entities come to your system. After that, simulation will not generate any additional entity and will not send them to your system. Okay, so the max arrival shows you the maximum number of entities that can come to your system. If you put infinity, that means for as long as you run the simulation, these entities will come to your system. And then first creation means these entities can be created for as soon as the simulation starts. When you put 0, that means there is no limit on when these entities should be created and be sent to your system. When you put 0, that means they can be created as soon as we start the simulation. If you have any limitation that, for example, you want to build your simulation such that the entities come to your system after 10 hours of the simulation, you can specify those here. So if we put those times here, and then in that scenario, then the entities will come after that specific time. But general, pretty much for every simulation we build in the class, we use 0 here, which means entities can be created for as soon as they start the simulation. Okay, so these are all the information we specified on the create. So as we said, the create module help us to specify anything related to the arrival of entities to our simulation model. Not only the inter-arrival process, but also if they are random or fixed, the unit of the inter-arrival time, if it's minute, if it's days, if it's hours, the number of entities that come together, how many entities have to come to our system, and the timing from which, from that point, the entities are generated and are sent to the system. So every one of these boxes are important. If you make a mistake in specifying any one of them, the entities that will enter your system will be wrong. Anything you conclude will be wrong. All the results will be wrong. And as I said, even for some scenarios, it can lead to errors. If you, for example, if you get the units of the inter-arrival time wrong, it can even lead to the errors. So this is a very, very important module. You have to get everything about it right. Okay, press OK and make sure to save so that you have these examples. If you want to later refer to it, that's fine. Now, when I click on the and this create module, you do see here at the bottom on the spreadsheet view, you see also the information related to this module here at the bottom as well. The name is part arrived to the system. The entity that is going to arrive to the system is part. The type is expression, one, the units is minute. So you can change any specification here as well. If the unit of the inter-arrival time is not minute and is hour, you can change it here as well. If the inter-arrival time, for example, you want to change it to the exponential, okay, great. You change it to the exponential, it's 5 minutes, and the unit of time, for example, is hours, and so forth. You can make all of the changes here. If the entity that comes to the system is not part, is something else, you can change that here as well. If you want to change even the name of the create module, you can change that as well. So this spreadsheet view pretty much shows the info, all the properties that we just touch here. So the spreadsheet view is just another alternative for you to change the properties of this create module. You can either change it here by double clicking on the create module, or you can change them here at the bottom on the spreadsheet module. Okay, if you create, as you put more create modules in your simulation model, for example, let's assume I'm also going to let another type of entity to come to the simulation model. So you see I drag and drop another create module, another row was created in the spreadsheet view. Okay, so in the spreadsheet view, now you can see the information of both these create modules that I have. If you have 10 create modules, you will have 10 rows here. Each one of the modules would have a row related to it, and you can change the information of that create module either here in the spreadsheet view or by double clicking on the module and changing the information here. Okay, so I'm just going to delete this one. And if you want to delete any one of the modules, just click on it, right click, delete, and it's gone, and then the corresponding row in the spreadsheet view is gone as well. When, remember here, when we created the create module, for the entity type, I said part. Okay, I said, okay, I want to simulate a manufacturing process in which parts arrive to the system, exponential inter-arrival time is exponentially distributed, average 5 minutes. And I call the entity, the things that come to the system, get processed and leave, I call the entities as part. So I'm in any simulation model we are going to do going forward, I'm going to call them as entity. I'm not going to call them as customers or parts or anything, orders or anything like that. Entities. When I say entities, you mean those objects that come to the simulation, get processed and leave. Okay. And I entered part as the name of the entity in this simulation model. Okay. So what if I want to give some information related to this entity that comes to the simulation? What if I want to make sure specific shape is used for this entity? What if I have 3 entities and I want to make sure so that I don't confuse the simulation? When the simulation is running and I see the animation, I want to see different color for these entities. Okay, so where can I see the information related to the entity? I can go to the entity module here, you see in the basic process here, if you click on the entity module, you can see the end. If you double click here at the bottom, nothing appears on the flowchart view, but here at the bottom, you see the entity. So it, as you can see here, it shows entity basic process. So here you see the list of entities that come to your system. Okay, so the first entity, the entity that I already have defined is called part. So although I defined the entity in the create module, however, an entity has automatically been created in the system and is shown in the entity module. Okay, so and that's what you see here. We can identify anything related to this entity, any characteristic here. So if there is any cost related to the waiting time of this entity, and so forth. So we'll talk about what these columns will mean later on. So I don't want to go into the detail of them, but what I basically wanted to show is that if I click on the entity module, here I see the spreadsheet view of all the entities that I have defined in the system. If I have defined 5 different entities, I will see 5 different rows here, okay? And here I define only one entity part, I see the information here. The 2 columns that potentially will help you here, I want you to know, one of them is the initial picture, which basically says, has a bunch of pictures already in the arena that you can potentially pick for to show how this part will look like when you run the animation of the simulation. So let's say here, I say, so here for the initial picture, let's assume I want to use blue ball. Anything that you want. I just pick blue ball. That means when I run the simulation, when parts come to the simulation, I see them as a blue ball. And again, it's helpful because what if I bring 3 different type of parts into the system? And when I run the simulation in the animation, I want to see each one of them as a different color. Here, I can come here and I can pick a different picture for each one of them. So when I run the simulation in the animation, then I can see which one is coming to the system, where do they go, and so forth. So that helps a lot. Okay, that's the initial picture. And the other one that helps is the reported statistics. We can either check or uncheck. Always have this as checked, because when we have it as checked, then the simulation generates some statistics for us at the end. For example, how long this entity was waiting in the system, how long this entity was waiting in the queue, and so forth, okay? So when we check the reported statistics, all of the numbers, all of the things that we want to know will be calculated for us. So I basically mentioned anything I wanted to say about the create module, the spreadsheet view, and the entity module. And remember, the entity is a data module. It's not a flowchart module. That's why for the entity module, I cannot drag and drop it in the flowchart view. I just see the information of that entity in the spreadsheet view. Okay, so that's the case with all the data modules. Anyway. So next, I want you guys to click on process here. They are still in the basic process template or panel. I want you guys to click on the process and then drag and drop it here. Okay. And I want you guys to click on it. So what this process flowchart module is showing us, the process module basically can help us to capture any operation that happens. So if we have machines, if we have people, like things that are performing some operation on the entities that come to the system, we can use the process module to show those process operations, okay? And here we can give them a name, let's say drill operation. Okay, so let's assume parts are coming to a manufacturing process, and then they get processed at this drilling operation. Okay, So what is their type? For now, pick a standard. I'll talk about that later. So for now, we pick a standard. Nothing is going to happen. Then we have to talk about the logic. Okay. So the logic that we put here, if you click on that, it has things like delay, cease, delay, release, and so forth. So let's pick cease, delay, release and see what it means. So the logic that we put here tells the simulation that when an entity gets to this process, what that entity will do with the resources that are there. So let's say here at this drill operation, if I have one drilling machine, what happens, what the entity is doing with that drilling machine? So the entity is going to first seize that drilling machine. It's going to get a hold of that resource, that drilling machine. Then it's going to impose some delay. The delay time that we have is basically the processing time that the entity has at that drilling machine. So first it's going to get a hold of that drilling machine. So that drilling machine, which is there right now, is just assigned to this entity. It cannot be used for anything else. Next is the delay time. So it's going to impose some delay on that machine. The delay time is basically the processing time. So the entity goes through some delay, meaning that the entity goes through some processing on that machine, and then the entity is going to release that resource, that drilling machine, and is going to go to the next operation, to the next module in the simulation. Okay, that's what basically cease, delay, release means. If I just pick, for example, the delay, that means the entity gets there and it's just going to impose some delay. There is no cease here, meaning that the entity is not holding any resource dedicated to itself. It's just a delay. For example, if I want to model traffic in a street, if I want to model a traffic light, the cars arrive, and when they are behind a traffic light, they're just there, and that time is just a delay time. They are just there for that specific time. They are not holding any resource. They are not releasing any resource, nothing. I just need to tell the simulation that when entity gets there, impose a delay on the entity. Hold it there for 2 minutes, which is the red light time, for example, and then let the entity go. In that scenario, I just show the delay. I just choose the delay. I don't choose any cease or any release, because the machines behind the traffic light are not seizing any resource, are not releasing any resource. They just have to be there for that specific amount of time. I have, for example, cease and delay, which means that the entity gets there. It's going to first get a hold of the resource. It's going to get one of the resources just dedicated to himself or itself, and then it's going to wait there for the delay amount of time. Okay, so it's going to be there for that specific amount of time that we are going to tell the simulation, and that's a delay time. And cease, delay, release, which we talk about, or delay release, meaning that entity is going to be there, wait for this specific amount of time, and then it's going to release the resource and then go to the next step. Okay.
Professor, Professor, what's the difference between cease, delay, release versus delay, release? Like so.
Okay, so in the cease, delay, release, the entity has to be there and seize the resource first. First, get a hold of the resource, then do the processing, then release the resource and go. Okay. In the delay release, if I choose delay release, for sure, we will get to examples. For sure, somewhere in the simulation, first I have seized a resource. Okay, so you have to seize a resource first somewhere else in the simulation, and then come here and just say, I'm going to have some work on this resource and then release it and go.
I see, thank you.
Sure. Sometimes we will have examples, sometimes based on the structure of the simulation and the way we have to develop it to capture some type of problem, we can't just say in one process, we do cease, delay, resource altogether. We have to separate them. We'll get to examples, you will see that exactly how it works. Okay, so for this one, let's say cease, delay, resource, okay? Cease, delay, release. And that means, as I said, seize the resource, do your work with this resource, and then release it. So then I have to specify what resource should be seized by the simulation model. So here at the bottom, you see the resource thing gets activated. You see, if I just choose the delay, there is no place for specifying any resource, because in the delay, you just wait there, do your work, and you are going. There is no resource there. You have not seized any resource. But when I use seize delay release, you have to tell the simulation model what resource you are going to seize, work on it, and then release it as well. So to be able to specify the resource, click on the add, and then here we can specify a bunch of things. So for now, just let it to be resource. We'll get to the set and things later. And let's give a name to this resource. Let's give it as drilling machine. Okay, so let's give a name to this resource, and then the units to be seized is 1. So this is important, guys. This means that when entity is there, it's going to use only 1 drilling machine. Okay, that doesn't mean that we have only one drilling machine in the system. If you are modeling a manufacturing process where you have 10 drilling machines, that 10 is something we specify somewhere else. That 10 doesn't go here. This number here just shows when one entity gets to that process, to the drilling process, how many drilling machine we want. We need only 1. Okay, so pay attention to that one. The unit here means when a resource gets to that resource, when an entity gets to that resource, how many number of resources we should seize. Okay, that goes here. But then that doesn't mean we have necessarily 1 drilling machine or 20 in the system. Okay, the number of resources that we have in the system, we specify them somewhere else. For example, if I'm modeling a hospital, if I want to model the operation in a hospital, and then let's say I have somewhere surgery, okay? The process that I want to talk about is surgery. This surgery is going to use a couple of resources, nurses, doctors, and so forth. And let's assume this in this hospital, we have 100 nurses, but for that specific operation, every time we have a surgery, I just need 2 nurses, okay? So then in that scenario, here the units to seize is 2. And the name of my resource is nurse, obviously not drilling machine. The name of my resource is nurse, and how many of those nurses I need to hold, I need to get a hold of how many resources to perform that surgery operation, 2 of them. That doesn't mean there are only 2 nurses in that restaurant. We may have hundreds of nurses that are working in that hospital, but how many I need to perform that surgery operation, 2 of them. Okay, so pay attention to that. Here I'm going to put 1, meaning that I only need 1 drilling machine to perform the operation. Okay. And that row is automatically added here as well for you. And here the priority part, I'll talk about that a lot later, but just know that here we can specify the priority of these entities that are going to be processed. Again, let's assume you are modeling a hotel. You have been hired by, I don't know, like one of the hotels to help them to find out, for example, how many agents they need at their check-in process, and you receive 2 different types of customers, the regular customers and the VIP customers. And all of them go to the check-in process that you have here. But these entities have different priorities. The VIP customers have a higher priority to get a hold of the agent who is waiting, who is standing there, and the regular customers probably should wait a little longer. In that scenario, you can specify the probabilities here, that the priorities here, that how this how this action of seizing the resource should be done and who should be given higher priority. Again, we talk about that extensively later in other examples. We have a big part about priorities and how we have to capture them, but I wanted to quickly mention that because this priority thing is important. Actually, it's helping you to capture a lot of complexities in the model, in the simulation models. Next, here at the bottom, we have delay type. So the delay time, at any one of these processes with any one of these resources, it's basically our processing time, right? So the delay time is basically our processing time. So what is the delay type? Is it a constant? If I pick it as a constant, I just put the number, the processing time at the drilling operation takes 6 minutes. So I put value of 6 and the unit is minutes. Again, make sure to change the units. If you forget the units, to change the units to the right value, you screw everything in the simulation, the results, the outcome, everything, okay? So if it's constant, I just put it as, put the value and then the minutes or the unit of time. And here, you can specify if this operation is a value-added operation or non-value added and so forth. Most of the times, when we have an operation that we have to perform on an entity, we pick value added. Later, I will tell you in other examples, when do we pick transfer, when do we pick wait, and so forth, okay? But this is basically the meaning of this. So if you are performing any operation on a part, that time is a value added time. The reason that it's important to specify those, because later when you run the simulation is going to tell you what is the value added time that the entity spent in the system, what is the non-value added time that the entity spent in the system. Non-value added time such as waiting in the queue and so forth. So if you know the value added time and the non-value added time, you can just focus on the non-value added time and try to reduce those, try to get rid of the queues that will be formed and so forth. So that helps you. So if I tell you in total entity stays in the system this long, okay, that's good, but you want to know how much of this time is value added time, how much of it is non-value added time, and your goal is to get rid of the non-value added time, which is wait time, queue time, and so on. Yeah, so if the process time is something like a normal random variable, you pick normal, you can specify the average and standard deviation. If it's triangular, you can do that, minimum, mode, and maximum. If it's uniform, you can specify the minimum and maximum. The notations is similar to the arrival process. And the same way we identify the randomness for inter-arrival time, we do the same for the process time. And then if it's none of these and it's just a more complex expression, you identify expression. And what is the next thing you need to do to identify the expression?
Right click on that step and
yeah, exactly. On the expression box, right click, you have the build expression here. Just click on that and then write down your complex formula, anything you want and so forth, and then click, and that formula will be used here to calculate your processing time. Okay, so let's say here, I just say constant 6 minutes. It's constant 3 minutes, okay? And then at the end, the report statistics box, make sure it's checked, because when you check this box, it reports some valuable statistics such as utilizations of these machines, how long they have been idle, let me see, and a bunch of other important statistics for these process operations. What is their waiting time? And yeah, all of that statistics are calculated if you check the report statistics box. And then press OK. Make sure to save. Everyone is okay so far? Any question?
Did we select the resource we created? I think it was just end of the list for
here.
Yeah. Oh, okay, interesting.
Yeah.
Thanks.
So here we said cease delay release, and then we have to specify the resource that we are going to seize and then release. And I pressed on the add button and I just gave it a name. So you can give it a name. I gave it the name of the drilling machine. So that's why now you see it here. I gave it the name of the drilling machine, and then it appeared here as well.
Yeah, sounds good. Thank you.
Sure. Now, two things I want to mention here. Did you see that I didn't have a resource called drilling machine before, right? I just created it in the process module and it just was created right away, okay? What if I wanna change some information related to that drilling machine, to that resource? Where should I go? Where should I go to change some information related to that resource that I identified, the drilling resource?
You have resource
data module.
Exactly, resource data module. If I click on the resource data module, you see the drilling machine, the name of the resource appears. So there's already one row created for this resource that we created in the process module. So it's already here. It's fixed capacity, how many of them we have, 1, and so forth, and reported statistics checked. Okay, so if I want to change anything related to that resource, I'm going to make those changes here. So here I say fixed capacity. What does that mean? It means that the number of units, the number of resources that we have is fixed and it's not changing in different times or so. And what is the capacity of that resource? The capacity of the resource means how many of that resource is available. Okay, the capacity of the resource is 1 here. That means we have only 1 drilling machine. But let's say in the nursing example, in the hospital example I told you, if I define a resource as nurse, and if I have 100 of that resource in any specific day for which I run the simulation, I'm going to put 100 here. So the capacity of that resource is 100, meaning that I have 100 of that resource in the system. Okay, in this example we have just 1 drilling machine. I'm going to just leave the capacity as 1. So this is important, guys, extremely important. When you click on the resource data module, the capacity is the place where you can specify how many of that resource you have that you are going to use in your simulation. Is the capacity the same thing that shows me how many drilling machine I'm going to seize for processing a part? Is that the same thing?
No.
How they are different? What does capacity show?
This capacity shows how many machines we could use or we could use at the same time.
Okay, how many units of the resource are in the system? If I have 20 drilling machines, then I put 20 drilling machines here, right? But the information that I specify here for the resource, when I click on the resource, if you click on the edit, the units that I'm going to seize, 1, it shows that when one entity comes and is going to get a hold of the drilling machine as the resource, I just need 1 drilling machine to process this entity, and that's it. I have 20 of drilling machines in my manufacturing plant, but I only need 1 to process 1 entity. Okay, so make sure you are not getting confused between the units to seize or release that we put here. Then we want to define a resource that is going to be used in a process, and then what we put here as the capacity. The capacity means number of resources that are available that can work in parallel at the same time. Here, pick one. Okay.
So if there's an entity that arrives at this process and there's not enough resource, will it just wait there, or do they cause an error?
So if I understood your question, so you said, what if entity comes to the system, but resource to process the entity?
Yeah.
It's causing an error, right?
Does it cause an error? Or
okay, I'll answer your question in one minute. Just wait.
Okay, sure.
Okay? We'll get that next. Before we get to that, I also wanted to check again, talk about the reported statistics, make sure it is checked, because when you check it, then it can tell you, as I said, some statistics related to the resource utilizations and so forth. And the fixed capacity, the type is fixed capacity, like, as I said, like if I put, for example, 20, that means during the whole simulation time, we have 20 drilling machine and we are going to use it, and that's it. But if I pick based on a schedule, that's the scenarios that, for example, if you model a coffee shop, for example, if you go to Starbucks, they have more people in the mornings to help. These are the resources, right? People in the counter who are helping us, who are giving us tea or coffee or things. Those are resources. So maybe 8 to 10, they have a lot more people to help us. And then between 10 to maybe 3 p.m., they have less. And then between 3 to 5, again, they have more people. So Starbucks, for example, has a schedule, how many people have to show up in each day and from which hour to which hour. So that means if I'm modeling the process of Starbucks, you have been hired by Starbucks to help them to find the right schedule for the number of people that they have to have and the counter in a day. So in that scenario, you can run the simulation model and you can specify how many resources you have at different hours of a day. And instead of just keeping it as a fixed number, you can define a schedule. From 8 to 10, I have 10 resources. From 10 a.m. to 3 p.m., I have 5 resources. And from 5 p.m., for example, to 9 p.m., I have 12 resources, right? So you can define the schedule for number of resources that you're going to have. And then in that scenario, we say number of units that they're going to have is based on a schedule. Again, we will get there. We'll get to all of that based on examples, but I just wanted to mention that you can do that with the arena. Okay, next thing. When you click on a process, you see there is a little straight line at the top. So that's where a queue is formed. If an entity gets to a process operation, and if all the resources here are already busy processing other entities, you don't get an error. This entity will wait in the line. And as we run the animation, that line will be formed here. You can potentially pick it and move it around if you want, but it automatically is put at the top of the module that we have, okay? So this is just a placeholder to form your queue as entities arrive. There's no space on the drilling machines to process this entity. They have to wait in the queue, and they basically, in the animation, they form a queue here. Once one of these drilling machines is done, they are going to pick a part from this queue, and they're going to start processing that new part and so forth. So you don't get an error. The part goes on the queue and gets processed. The simulation model tracks all these times that the parts are waiting to get processed. And these waiting times are non-value added times. Simulation at the end, when it reports to you how many times a part waited, how long a part waited, it calculates the time that this part waited in the queue. At the end, it reports it to you. This is the waiting time. So you can know, okay, the waiting time is long actually. That means I have to do something. I either have to buy more drilling machines or do something, but the waiting time is long. Or no, waiting time is actually short. So it's a good thing. Okay, did I answer your question?
Yes. Yeah, I got it. Makes sense.
Perfect. That, and then the next thing I want you guys to do, if you guys can click on the queue data module here, you see there is a row automatically calculated. It says drill operation queue. So drill operation is the name of the process that we specified here. So the simulation automatically creates a queue for the drill operation so that entities that cannot be processed right away wait in the queue. The queue is here, and again, make sure the report statistics is checked, because that will calculate for us what is the length of the queue, how long these entities wait in the queue, and so forth. And remember, we need all of that to be able to evaluate performance of this system. And the part that is extremely important is the rule here. So you see, we specify the queuing rules here. So when these parts wait in the queue, is there any rule associated with this queue in terms of which one of them is the one that is going to get processed first? Is it first in, first out? Is it last in, first out? Or are we specify the priorities based on something else, which again, We will try all of these in different examples that we will do in class. But I wanted to specify that because this is actually very, very, very important as well. The priority thing in simulation generally is very important, and it helps you to capture a lot of complexity. So make sure you guys know exactly where to specify the priorities associated with the items or the entities that wait in the queue. Priorities in terms of which one of them is the next one that has to go and get processed on the drilling machine. So these priorities can be specified here. We'll get to them. In different examples, we try different priorities, so you will know. The other module that is important, and I want you guys to please practice it with me, is Dispose Module. So click on the Dispose Module, drag and drop it here. Okay, so what does Dispose Module do? The Dispose Module is really, really simple. All you need to specify is to specify the name, dispose entities, or dispose, or okay, let's say send the part. Okay, so when an entity comes to the system, it gets processed and everything, you cannot just leave the entity in the system. You have to send the entity out, and that is done through the Dispose module. So you have to send the entity out of the system. So when entities come to the system, either they circulate or they have to leave the system. They cannot just wait somewhere in the system forever. That's not going to happen. If you have something like that, you will get an error. If you have an entity that you haven't, it has gone through some process, it's done, but you haven't sent that entity out of the system, you will get an error when you run the simulation. So how to send an entity out of the system, out of the simulation? By using the Dispose module. So when you have Dispose modules, that means that entity is going to be disposed, and the only thing that you have to make sure is to give it a correct, give it a reasonable name, and make sure to also check the record entity statistics so that it records the statistics for you, such as how long the entity has been in the system, how many entities are leaving the system, and so forth. Okay, and that make sure to save what you have done so far. The next thing that I want you guys to do is for us to be able to make sure this simulation works, entities come to the system, they get processed here, and then they finally leave the system. We have to connect these modules together. And to be able to do that, there is something on your menu, it's called Connect. If you click on it, it's here, Connect. It's also, if you click on the Object menu, there is a Connect option. If you click on that, that works as well. Okay, when you click on that, then you come here, click on this side of the create, oops, oh, sorry. So if you click on the connect, then you see it like a cross. Your cursor will be like a plus sign. So click, and when you click on the end of this module, you see it's and a square is created. So click. And then when you click on the other side, on this other module, and again a square is created, then click. Okay, so that connects these two modules together. Okay, again, the end parts that you have to, again, I'm going to click on the connect. Again, clicking on the drill module, a square is created, click, and then clicking on the dispose module, a square is created, click. Okay. If you have, if you want to create the connections multiple times and you don't want to click on the connect several times, you can just double click, then you will have the connect active. So you can do multiple connects and still you have it as connect. So you don't need to click on the connect in the menu several times. And if you click on it, then it's deactivated. Okay, so that way we connect the modules and then we can tell the simulation, yes, here is the entities are created, then they go to the drilling operation, then they go to the dispose module, and then they're leaving the system and they're done. Okay, then that forms a simple, small simulation model for us. So let's review quickly what we have done. Entities come to the system, we call them as parts. the inter-arrival time has exponential distribution, 5 minutes. So pick it as 5 minutes. I want the inter-arrival time to be 5 minutes, one at a time for as long as I run the simulation, and they can come to the system from the start of the simulation. And they go to the operation, they cease, delay, release the drilling resource. They are going to use one drilling machine, and the operation time, I want it, let's assume it's going to be constant, and it's going to be 3 minutes, and that's it. Okay. And then the dispose, okay, so it's going to dispose the resource when it's done. Okay. So now let's, okay, before we run the simulation, we have to specify a couple of things for the simulation, such as what is the simulation time? How long do we want to run the simulation? So those things are specified in the run simulation setup. Okay, so if you click on the run and then on the setup, we can specify a bunch of things here. So there are a lot of tabs here. The ones that you probably work with it more often is called Replication Parameters. So click on that tab. I don't know which tab you are in, but click on the Replication Parameters, okay? And on this one, for now, I want to pick a number of replications as one. Later, we'll talk about what replications means and so forth. Warm-up period, I want you to keep it as 0. Later, we'll talk about this warm-up time means. For the replication length, I want you to specify it as 10 hours, okay? And the hours per day is just 24 of them. And for the base time unit, which is the unit of time that will be used in the simulation, use hours. Okay. So what I said was that if you want to run the simulation model, we want to, for example, specify how long we are going to run the simulation model, and a bunch of things that later we will learn. We specify those in the run setup. Go to the run menu, click on the setup, and then go to the replication parameters. And what I want you to do now is to just replication length. For the replication length, okay, sorry, specify 20 because that's the numbers I have. I ran the simulation for 20 hours. So keep it as 20. The time unit is hours, meaning that I want to run the simulation for 20 hours. Hours per day typical is 24 hours per day, and the base time unit just keep it as hours as well, and then press OK. Here, if you, on the menu, you see there is a button similar to play button. If you click on it, it says go. Okay, so I press go, and you see the animations. So the blue balls that we specify as entities that come here. The simulation has run to completion. Would you like to see the results? Yes. And the results is created for you automatically. Everyone has the results. Were you able to run your model? Did it work? Yilin, are you here?
Yes, I'm here.
Can you please share your screen? Let me see your results.
Yeah. Wait a second.
Stop sharing. And then let's. Oh, perfect.
Can you see the screen?
Yeah. Perfect.
Okay.
Thank you so much. Lucy, can you please share your screen? Let me see.
So after I do this part and some problem of my computer. Sorry for that.
No worries, no worries. When you run it, okay, could you change the parameters? Yeah, replication parameters. And just replication, no. For
here 20, right?
Yeah. For that one, change it to 20 and everything else. Run it. Okay, perfect. You have some results.
Thanks.
Okay, thank you. So I created the results, and this shows the number of entities that leave the system is 2014. Here on the left side, you see here, unnamed project. Do you see something like this?
Yes.
Entity queues and resources.
Yes.
Okay, perfect. I don't know what was wrong with that one. I'm not sure. This is a run. I'm not sure exactly. It's 20 hours, but I'm not sure exactly what are the parameters of the model. So if your numbers are a little different from me, no worries. I may have different parameters on this run that I did earlier today, but anyway. So if you click on it, when you click on the entities, okay, here is what you see. And if you open the plus sign, so you see the time, okay? So what does it show? That shows for the entities, which are parts that came to this manufacturing process, VA time. What does it show? Value added time. That shows for the entities that came to your system. On average, what is their value added time? The time that they spend in the system. Since we use the time unit as hours, everything that's shown here is shown as hours. That this is 0.05 hours. If we had picked the time unit as minute, everything that is reported to us will be in minutes. So maybe that was a little easier to discuss. Okay, but just keep that in mind. If you want to get the results in minutes, you can always change your time unit, base time unit, and then it will calculate everything in minutes for you. Yeah. So here we see the average and then some minimum and maximum for the value added time that we see here. Can someone tell me what this number means? So forget about the magnitude. So let's assume this is 0.05 hours. So, but how the simulation calculated that, the value added time of the entities in the system?
I think it just keeps track of like when it enters the system and when it leaves the system, and it adds the time it spends in the machine, and then it takes the average of the whole population, maybe.
Okay.
That's the average.
Yeah, so almost, yeah. Thank you so much. So what happens in the simulation, guys, is that every time an entity comes to the system, when it gets to the areas where value added time, remember for the processing at the drilling, I said it's value added. When that entity gets to the drilling, it's going to record it as value added time. And when for that entity, when the entity leaves the system, so one record is created. Then second entity comes, another data point. Third entity comes. For that third entity also, it's going to see how long the value added operation, which is the drilling operation, would take. It records the time. So at the end, if let's say here, I say that in my simulation, if 200 something entities left the system, I have 200 something value added time for each one of those entities. And at the end, the simulation calculates the average of all of those times and their mean and max and reports those values to me. Okay, that on average in this system with this setup that I identified, on average, parts will spend about 0.05 as their value added time. What is the non-value added time? 0, because I didn't define any non-value added operational process. What is the wait time? When the waiting happens in the system? When does that happen, the wait time?
Yeah, if somebody just sees the machine and it's using, the others have to get in a queue, right? So
the waiting time happens when the entities go to the drilling machine, but the drilling machine is already full processing other entities. So these new entities have to wait in the line, have to wait in the queue. The simulation will automatically calculate all of those as the waiting time. Okay, so for each one of the entities that come and they have to wait in the queue, simulation waits. Oh, how long did you wait in the queue? 2 minutes? Okay, 2 minutes for you. The next entity, did you wait 3 minutes? Okay, 3 minutes for you. Calculates all of these waiting times for all of these entities, and then at the end reports their average, their minimum, and their maximum. If there is an entity that comes to the drilling machine is empty, goes right away, gets processed, the waiting time for that entity is 0. So 0 will be one of the values that will be used in calculating the average as well. Okay, transfer time. We don't have any transfer time here, but later we do simulations that in which it takes time to pick a part from one machine and take it to another machine. That's used as transfer time. And then finally, other times if you have anything else, and then total is the total time. What is total time in simulation? In this system, what is total time? What does it show?
Total time spanning system.
Okay, what are the components that go into total time?
Entity.
Okay, the time of the entities, but
Oh.
time of is the queue, the time waiting in the queue, and
Process time.
exactly. When we say total time, it's the times that they wait in the queue and the processing time in the machine. That's the total time they wait in the system from the moment they come to the system till the very end when they are finally leaving the system. That's also important value to know. Okay, the total time is important, the wait time is important, the value added time is important. So we want to know all of these so that we know if they wait in the system for too long. If most of the time that they spend in the system is waiting time, okay, we have to somehow solve this issue. Okay, and number of entities that came to the system, number of entities that left the system. Number of ins means 249 entities came to the system, but only 248 left the system. What happens to that one entity that has not left the system? What happened to it?
That entity is still processing in the drilling operation.
Exactly. When I stopped the simulation, I stopped it after 20 hours. So maybe at that time, that entity was still being processed and hadn't finished the processing yet, but I just stopped the simulation. So that's why the number of entities that have left the system that are out is less than the number of entities that came in. The one other important, very, very, very important part of the report is work in process. What is the work in process?
The entity wait in a queue. Is that correct?
Resources that are in the system or waiting to be processed in the system.
Exactly. They are somewhere in the system. Either they are in the queue or being processed at the machine, but they are still in the system. They haven't left yet. Okay? So either they are waiting on the queue or they are being processed, but they are somewhere in the system. That forms the working process. And in the manufacturing operations or even the service industry, that value is very, very, very important because those are customers waiting in your system. Those are parts just sitting somewhere in your system. You can just process them, send them out, and make money. So you don't want to have too many work in process. You want to monitor these characteristics so that you can reduce it as much as possible. So in this system, on average, we have 1.5 part sitting somewhere in our system. Okay, minimum 0, meaning at some point we have had no part in the system. Max 6, meaning that at some point we have had 6 parts in the system. And given the fact that in our system we have only 1 drilling machine, if we have had 6 working process, meaning that one has been processed, one was being processed in the drilling machine, and the other 5 were being were waiting in the queue. Okay, and then if I go on the queue, and if I click on the queue here, I see a bunch of information related to the queue, the waiting time in the queue, the number of parts that are waiting in the queue. Remember when I was telling you the queuing system concepts, I told you all of those notation, L, LQ, W, WQ, the notation that we have in the queuing theory in terms of number of parts waiting in the queue, number of parts waiting in the system, the time waiting in the queue, the time waiting in the system. You can see that all of those are automatically generated by this report and calculated by this report for us. You can see the utilization of the resource, 70% utilization. I will tell you later what is instantaneous utilization and so forth. So we don't have enough time today. But I will go more over this this example, what we see in the report for you. So guys, the class time is over. What I wanted you guys to do, I will assign some problems, simple simulation examples, and I want you guys to do it. Okay, when I assign the problem, I will tell you guys if it's individual, meaning that all the people in the group have to do it. If it's group-based, meaning that you have to do it in the group and submit just one. So when you get the homework, if it's individual assignment, means that 4 people have to submit that assignment. In the folder that you're going to submit, I need 4 of that assignment. And then Any questions so far, guys? Good.
Sorry, Professor, I'm still a little bit confused about the VA time.
VA time? Okay, which part of it?
Can you expand it again, because I still not quite understand it.
Okay, sure. See, so when a part comes to the system, right, VA time is value added time. If a part comes to the system and waits 1 hour to get processed, and then finally goes to the machine, and the whole processing time, the whole drilling time takes 10 minutes, right? This part has been in the system 1 hour, 10 minutes, right? But what part of this waiting time has been a value added time, that you really did something on this part to add value to it? Which part of this time was an important time, a value added time?
Processing entity?
That 10 minutes. So the part came to the system, the drilling machine was full, right? The part waited in the line, and it waited in the line for 1 hour. Finally, the part got to the drilling machine and it got processed, and it took only 10 minutes to process this part. Okay, so the part in total has been in the system 1 hour, 10 minutes. But was all these 1 hour, 10 minutes that the part has been in the system is the time that we really did something for this part and changed it in a way that added value to the part? No, right? Which part of this 1 hour, 10 minutes was the part that we did something on the part and we changed it and we added value? Only that 10 minutes that we processed the part, right? The 1 hour that the part was waiting to get processed, nothing happened. That's not a value added time. That's just a wasted time. That's the waiting time. We don't want a part to wait 1 hour, right? We want to reduce that waiting time, and we want to just keep the value added time. In an ideal scenario, I want a part to come in, no waiting time at all, get to the drilling machine, get processed 10 minutes, and leave the system. That would be ideal scenario. In that scenario, the value added time is the only time that we have in the system. So value added time is the time in which we do something on the part so that we can sell it more expensive. So we provide some service, so we process the part, okay? And we calculate value added time because at the end, if you have the total time that the part spends in the system, you want most of it to be a value added time. If most of it is not value added time, that means the part has been waiting most of the time, and that's not good. Is that clear?
Yeah, thank you.
Sure. Sure. Okay. So I'm going to give you an assignment, simple simulation models that I want you guys to finish and submit. One thing I want from you is the name of your group members. Let me see. Have you guys emailed me, all of you, the name of the group members? 3 or 4. I got an email of a couple of you that don't have a group, and I will assign them. But is there anyone here who does not have a group member and has not emailed me? Everyone is okay? Okay, so I will create a group for each one of you in Blackboard, and I will explain in the email that I will send how you have to submit this homework. Is there any question? Make sure to save the model that we created in the folder for week 1. We are going to use it in the next session, and we go from there. If there is no question, guys, let me see, and there's no question in the chat. Okay. Guys, on the Slack app that you have, I'm not there, I don't see it. So make sure to email me the name of your team members, guys. So just one of you, send me an email and tell me these are the name of team members, and make sure to put their email address as well, so that I can easily find them and make the groups for you. If there's no question, that's the end of the session. I will post the video in a day or 2. I just need to edit it and extract the parts that we don't need. Is there any question? Have a good day, guys.
Thank you.
Thank you.
Thank you, Professor.
Thank
you.
you. Sure. Have a good day.
Thank you. Bye.
Sure. Bye.
Hi, Professor.
Yes.
I got a question about the report of my simulation. It's like, can I share my screen with you?
Sure. Go ahead.
Wait a minute. Let's see. Okay. It's like, sorry, do you know how to share the screen? Because I don't really know how to share the screen.
At the bottom, you see.
Okay, I got it.
Yes,
thank you. It's like, can you see that right now?
Okay, I can see it now.
Yeah, it's like when I try to run the simulation and see the report, I see a warning. It's told that the Crystal Reports runtime engine is required to do so, and I'm not installed that. So I wonder how can I install that?
It's an error that I saw last year as well. It's related. So when you run this model, do you save this model on your computer or on the desktop?
I haven't saved that.
So you have to save it first.
Okay, so I have to save it first. Like, wait a minute. Let me see. So, how can I save this? Because you can see it's come into the gray area, and I can't really.
First of all, you have come all the way to the end, and you have not saved your model. Okay, that's not good. If you do that in the exam or in the homework, and suddenly you lose everything, I'm not going to have any mercy on that. Okay, so when you create a model, the very first thing you have to do is to save the model and to save it frequently as you build the model.
Okay.
Okay. The next thing,